Welcome to the next video of our specflow video series. In this video, we'll be talking about separation of concern, and we have been talking about some of the advanced concept of automation testing along with specflow. Separation of concern is one of the most important concepts while writing the better automation code, and we are going to be talking about that in this particular video. Before we understand this separation of concern, let's talk about the solid principles. Solid is a 5 design principle which are fundamental of software development. The S in the solid stands for single responsibility principle, O stands for open closed principle, L for Liskov substitution principle, I stands for interface segregation principle, and D for dependency inversion principle. And that's about the solid principles. And the reason why I even introduced this solid principle is to talk about the separation of concerns. Because separation of concern is also more fundamental principle of software development and implements 2 out of 5 solid principles in it. And they are single responsibility as well as the interface segregations. The single responsibility in a nutshell is this. A class should only have a single responsibility, that is, only changes to one part of the software specification should be able to affect the specification of the class. We don't really get what it is. We are going to see this in a code. Interface segregation is this. Many client-specific interfaces are better than one general-purpose interface, and that's exactly what we are going to be trying to do in our code over here. Let's quickly see the whole theoretical aspect into a practical demo in this particular video. And as you can see, this is a very super simple Selenium C# code which has a specflow scenario, something like this. And it's going to perform a simple navigate to the application, perform a login button click, and then enter the username and password. That's the simple scenario, and the step definition for this particular operation is implemented over here. It also uses the Selenium's page object model code, which has actually been initialized in the constructor using the driver pattern. It also uses the power of context injection to perform a dependency injection of the objects like the driver fixture, homepage, as well as the login pages. And the homepage and login page is going to look something like this, which is going to have the initialization of a driver fixture and then perform the UI operation using the page object model code. And that's going to be the same for the login page as well. And that's about the simple code over here. But the problem with this code is it doesn't really uses the solid principle efficiently. It only uses the context injection like driver pattern, but it doesn't really uses the interface segregation principle as well as the dependency inversion principle more efficiently. In order to achieve the dependency inversion principle more efficiently, we are going to first create the dependency injection and make the changes in the code a bit to make it more readable and more efficient. So for that, we are going to first install solid token.specflow.dependency injection library within this particular project, and this way it is going to start performing the dependency injection for us. And we have already discussed about that within our specflow video series before, so you can go ahead and watch that particular discussion. And once we have this library installed, we then require one of the most important class to be created so that this particular library can be worked efficiently. So for that, we are going to first create a new class file. I'm going to call this as startup, and then we need to add the implementation over here. But before we start adding the implementations, we then need to talk about the interface segregation itself. So in order to do that, I'm going to first go to this login step over here. And as you can see, we have used the simple context injections of the specflow to pass the concrete class of the driver fixture over here. In order to avoid the concrete classes and to use the interfaces, we can actually create the interface for all these concrete classes as well using this. If you just hit control dot, you will see there is something called as an extract interface. And once we hit this extract interface, we can then create an I driver fixture, something like this. And as you can see, it has added an I driver fixture for me, and has also created a class file separately over here. And this is the one that we can use to call within the step definitions files over here. So we can replace this driver fixture to I driver fixture, and this way it is going to start using the driver fixture itself, which is going to be coming all the way from the interface for us. And similarly, we can start replacing the home page as well as the login page as well. In order to do that, I'm going to hit control dot and extract the interface, but I'm going to add it in the current file so that we don't really have to create a separate files for it. And similarly for the login page, we could do the exact same thing by extracting an interface and add it to the current file. And you will see that it only has the declaration of the method rather than the implementation itself. Once again, instead of the home page, we can just use the I home page, and for the login page, we can use the I login page. And the same thing we can do over here on the constructors as well. Once we have all these detail, we don't necessarily need to call the concrete classes like how we have did before using the driver pattern. So we can just get rid of it completely, and we can just do the initialization of the field for the home page as well as for the login page, something like these. And once we have these members, the rest of the code is going to remain the same because this is not going to be affected, because we are just going to call the interface which has the declaration of the member, like click login, as well as perform the login operation on the interface itself, as you can see over here. So we have already implemented the interface, and now we need to call the dependency injection in a better fashion. In order to do that, we're now going to fall back to the startup class file, where we are going to add a method which is going to perform these operations for us, something like this. So this is the iService collections of create service class file, which is going to call all the interfaces like iDriver fixture, iHomepage, iLogin page, and then it's going to register all the dependency injection on the container, and this is what is going to be used within this particular step definition file. So let's go ahead and add all the missing references by hitting Control dot. And once we have all these things in place, now you will see that the code is even more maintainable, and it uses the solid principles within our code, and it is a well engineered code for us. And as you can see, now we can use the same iHomepage as well as the iLogin page in any step definition file of this specflow, and we can still gain access of all the members because it's been registered on the startup class file over here, so that we could use the same iHomepage as well as the iLogin page in any step definition class files. Let's try to run this code and see what is going to basically happen. So you will see that it opens the application as well as it's going to perform the login operation and closes the browser. It's all happening because of the dependency injection of the specflow as well as the interfaces that we have declared. This makes our code more readable, maintainable, and it is also implementing most of the better engineering practices within our coding standard.